A girl stands at the edge of a quay and sees a tin can floating in the water. The water level is 5 meters below the top of the quay, and the can is at a horizontal distance 10 meters from the quay, as shown in the diagram. The girl decides to throw a stone at the can. She throws a stone at a height of 1 meter above the top of the quay. The initial velocity of the stone is 8 meters per second at an angle alpha below the horizontal, so that the initial velocity of the stone is directed at the can, as shown in the diagram. Assume that the stone is a particle and that it experiences no air resistance as it moves. Find alpha. Find the time that it takes for the stone to reach the level of the water. Find the distance between the stone and the can when the stone hits the water. So that's the question then. I've got it in summary form here. First of all, we need to find alpha. Okay, so the height here is 5 plus 1 meter from where it is thrown, so that's a total of 6, so I've put it in here. The distance across is 10. The angle, this is a triangle here, a straight line here is the initial projected velocity, this direction of the stone. So we can work out the angle alpha, can't we? It's just the opposite tan alpha. So I'll put it in here to save space. Tan alpha is equal to opposite over adjacent, which is 0.6, 6 over 10. So that tells us what alpha is equal to then. Shift tan 0.6. Tan 0.6. 30.9 odd degrees. So round it to 3 significant figures is 31.0, isn't it? And that's to 3 significant figures. So there's alpha. Find the time taken for the stone to hit the water. Okay, so it's going at, this is part B now. So we can use v squared equals u squared plus 2as, because we know the total distance, we know the acceleration due to gravity, we know the initial downwards direction of velocity, and then we can get v then, and then we can put v in here into u plus at, because we know all the others, a and u, and then we'll know v, and we can work out the time. So let's use these two and combine them. So 8 and alpha. Don't forget that the stone is thrown down here at a speed initially of 8, and this is a triangle here, the sides of which, this one was 10, wasn't it? And this is 6. This is alpha. So using Pythag, 136, 136, square root 136 then is this side. So the initial velocity downwards, let's just put this in the diagram, will be down here, and we'll have 8 cosine of this angle, which is sine of this angle. So it's 8 sine alpha, that's the initial speed, which is 8. Sine alpha is 6 over root 136. So there's our initial downward speed then. So v squared. So downwards then, in the downwards direction, v squared is equal to u squared, so that's 48 squared over this squared, which is 136, plus 2a, acceleration is g due to gravity, times the distance s, which is going to be the vertical downwards distance is 6. So v is equal to then, and we can tap this in the calculator, can't we? So it's 48 squared divided by 136 plus 12g plus 12 times 9.8 equals, and then square root this answer then to get v, because that was v squared, 11.599, 11.599, which equals 11.6, and that's to 3 significant figures. So there's our velocity then. So That's the velocity. Now we can find the time taken, which is what we want. So this 11.599 then is equal to the initial velocity downwards, which is this 48 over 136 square rooted, plus acceleration due to gravity times the time. So that tells us what the time is then. T is equal to the 11.599 minus 48 over the square root of 136. Now that's GT. I've moved this over as a minus here. GT, the G is still here, and I'm going to move the G now from times down to divide in one fell swoop. So T equals then. Now we already have this number in the calculator, so we need to, here it is here, minus 48 divided by the square root of 136 equals, and then divide that by G, 9.8. 0.764, 0.7635, which equals 0.764 to 3 significant figures. So there's the time then for part B. That's seconds. So that's part B then. Now part C. Find the distance between the can and the stone when it hits the water. So the horizontal distance of the stone first of all then. Horizontally. We want the distance S of the stone, how far the stone comes out from the key, is ut plus half a t squared. Now we know the acceleration horizontally is 0, so S is equal to u times t. U horizontally will be here, 8 cos alpha, which is 8 times 10 over root 3, 136. So 8 times 10 over root 136, 8 cos alpha, times the time, which is 0.7635. So that's equal to then, this number's still in the calculator, so times it by 80, times by 80 then, divide by the square root of 136, equals 5.238, 5.238. So the answer then, that's how far the stone goes out from the quayside edge, but the total distance, the distance between the can, which is 10 meters away, and this, which is 5.238, will be, the difference will be the distance between the can and the stone when it hits the ground, won't it? So if we take 10 away from that, minus 10, we'll get the difference, even though it's negative. We can just read off the positive. 4.76 meters. So there's the distance between the can and the stone when it hits the ground.